Good day, folks. This is the first tutorial in a new playlist that I'm creating, which is called Dynamic Scenario Mechanisms in 3D Experience as Release 2025X platform. Now, first of all, I want to mention that what's buried inside of these mechanism applications in 3D Experience is the good old CATIA V5 DMU kinematics, and it is the primary engine for these applications. The applications within the 3D Experience are called mechanical systems design and mechanical systems experience. However, I want to point out that uh, the dynamics calculations cannot be done in the DMU kinematics module within CATIA V5. Okay. Uh, However, they have expanded that in the 3D experience so that you can do very basic uh, uh, dynamics calculations. Now, as of today, December 11, 2024, I have seen very little uh, documentation slash help slash tutorials on the dynamics modeling for the application that we're looking at. Now, the only ones that I've seen, there are four of them, and it's by this gentleman on YouTube. But these were done 4 years ago. Things have changed quite a bit since then. So let's quickly look at what if you are familiar with the previous or the playlist that I already did, kinematics scenarios dot dot dot. You are familiar with this set of icons at the bottom of the screen when you go there. Now, when it comes to scenarios, you can either do kinematics, which is right here, kinematic scenario. All right, and I have done the entire playlist on it and it's evolving. Or you can do dynamics, and this is the focus of the present playlist, not the kinematics one, because the kinematics one is already done and I've prepared many video tutorials for it. So when there's one thing you have to do, as soon as you say dynamics, as soon as you try to create dynamic scenarios, something weird happens because you have to have some masses. Remember, dynamics means in the nutshell, kind of F equal to ma. As soon as you say F equal to ma, dynamics, you need mass. So there's something very strange happens, and that is assigned weight definition. Now this may be partly because this was the expanded version of the MU kinematics. Okay, therefore maybe not a lot of thoughts were put behind it. But anyway, you have to do this weird thing, this rather awkward thing when it comes to the dynamics scenario calculation. Before that, in the mechanical system design, this is not the mechanical system experience. It's a mechanical system design. You have to click on this thing and you put some other dummy masses on it, depending on what you're looking at, or actual the mass of the objects that are kind of moving. Now, the goal of this playlist is to create, to use dynamic scenario, not kinematic scenario. This should be dynamic scenario, not kinematic scenario. And once I do a problem, I look at the results and compare it with, if available, some analytical calculations that it must match. One of the drawbacks of those four tutorials that I already showed you or mentioned them is that things are done, but there is no discussion on is it right, what exactly is going on. So the purpose of this tutorial, this playlist, is not only to do the tutorial and show you how you go about doing it, and then when possible, try to match it against the uh, hand calculation. Okay. All right. So this was tutorial one. There are many other ones that are going to be created. So tutorial one is done. Tutorial two is going to be dealing with the accelerating block, which was done earlier in the other playlist, but now using dynamics scenarios. Okay. Good luck.